Now let's solve the first question here and second and third on that momentum. And I want to listen. They are interesting questions anyway. Now, the first one says what? High-speed photography reveals that when a bat strikes a ball, a typical collision time is about what? The collision time is about 0.25 seconds. If the speed of what? The speed of 25 what? Meter per second is impacted on the ball of mass. What is the mass? 0.325 kg. So what is the average force? The average force is going to be mv minus mv over t. So in this case, now for us to solve, we use this formula, which is what? 0.325 times what? U is already 0, so you will assume U is 0. So we are going to use V 25 all over what? 0.25. Quickly, let's press calculator to see how what. Although this one will give us what? 32.5. Yes, it will give us 32.5. That is the first question. Let's go to the second question. We have two more to go. Number 2, we have what? A football of mass 90 kg running back. Since it's running back and moving with the speed of what? We are going to take the what? The velocity as what? Minus 5 meters per second. Is tackled head on by a linebacker of mass. What is the mass? Let's call it M2. That one is what? 120 kilogram. Running 4 meters per second. So U2 is what? 4 meters per second. And is what? That is the speed. See, they stick together. For this statement, stick together is an inelastic condition. So we would have M1U1 plus M2U2 equal to what? M1 plus M2 times what? V. So what's our M1? 90. M2 is what? Minus 5. Anytime you hear running back to the left, that word, all those words are to the left, in the negative direction, opposite to the word, to the body that is moving in the right direction, that means that it's negative velocity that you are going to use. Plus what? So 120. Once you hear left, to the left, opposite, back, running back, all this is a negative velocity. So in that case, I would have what? 4 equal to what? What is our mass? 90 plus what? 120. We play with it. So this one will give us minus 450 plus what? 480 is equal to what? This one will give us what? 210 V. So that will give us minus 450 plus 480 will give us what? 30 equal to 210. Divide both sides by 210. So this we cancel this. So I want that V is equal to what? 1 over 7. What is 1 over 7? 1 over 7 should be 0.14 to thereabout. 1 divided by 7, 0.1429. Yes, exactly. So 0.1429 meter per second. So that is our what? Number 2. Now, that is, we have calculated, let's say what? How fast we have calculated, that is the speed. Now let's solve the last question. He said what? An 18-kilogram fish moving horizontally to the right. To the right. Which once you hear that word to the right. So the mass 1 goes to 18-kilogram what? Fish. That is a big fish indeed. Moving to the right with the velocity. Velocity of what? Let's say U1 is what? 3.2 meters per second. Moving to the right. Swallows a what? A 2 kg fish. So that means initially the 2 kg fish is what? Is 2 kg. The mass of the small fish is 2 kg. That is swimming to the left. That means the fish is moving to the left. So for it to move to the left is minus 7.4 meters per second. I just told you now, to the left, negative. Now, I say, what is the speed of the large what fish? This is large fish based on the mass. You have M1, U1, you have forgotten our M2. Oh, this is M2, U2. already. So now what you want to do now is, let's say, what is the speed of the large fish immediately after it launched? That means he swallow it, so he uses the small fish as for lunch. He uses it for lunch, and for it to swallow it means that that is a typically inelastic condition. So in that case, you are going to have what? M1U1 plus what? M2U2 is equal to what? M1 plus what? M2. And when you swallow it, the fish, the velocity of the bigger fish or the large fish is what we call the common velocity, because already small fish is inside the big fish. So they say what if the force exerted, because the water will exert force on the fish, but the water can be neglected. So we neglect it now, because in using this formula, no forces from the external what body must be what acted. They told us that momentum before collision must be equal to, according to law of conservation of momentum. He said the total momentum before collision must be equal to total momentum after collision, provided what the system is what isolated, is not what exerted by what, is not under the influence of external force. So that is the only way it can happen. That's why they are trying to give you the condition so that you can apply this formula. So I would have 18 times what is 3.2 plus what? 2 into bracket minus 7.4 is equal to what? 18 plus what? 2. That is 20. Well, let's play with it. So 18 what? Times what? 3.2 is what? We are going to have what? 57.6 minus, plus and minus is minus. Then this one will give us what? 14.8. Let me tell you, 7.4 times 2. That is 14.8 exactly. It's equal to 20V. So what I want to do now is for 57.6 minus 14.8. So I want to have it as 42.8 equal to 20V. So how do you make V so the formula? Divide both sides by 20. So if you divide by both sides by 20, what we have? Divide both sides by 20, I would have 2.14. Yes, 2.14 meter per second. So this one will be the velocity at which the larger fish will be running with, or after it has used the smaller fish as for lunch. This is a typical inelastic condition. I believe we have what? Enjoyed this class for 1 to 3. See you in my next video. Thank you for subscribing and for watching.